Hi, this is Kirk Jackson,
And this is Tommy Sherbel.
and we're here to present our project for GIS programming for BYU winter 2014. We chose to do a unique project, not one of the standard ones listed, and so we'll spend a little bit of time describing the problem statement, and then after that we'll take a walk through the code and show you some of the tricks that we came up with in the code. And then after we're done with that, Tommy's going to describe how to work the script and a little bit about the input and some of the results. So first of all, just a little bit of background about the problem. I used to work at a place called the LTAP in Logan, Utah when I was going to school there. And they did a lot of pavement distress surveys. And so they often will go out, they'll hire summer interns to go out and they'll look at every section of roadway in one city. So I happen to have the data for Provo City that they went and inventoried in 2011. One of the things that is important about how they measure the quality of the pavements is that the methods they use are outdated. So what we've done with our project is we have created a program which updates their methods to a current modern method. A little bit about the data that we're working with here. All of the inventory data is stored in a database, which you can see here. You can see the second column is road name, from and to addresses. Has lots of data: the width, the length, calculates the area, what type of surface it is, be it asphalt or concrete. The functional classification, the date that it was inventoried, and then a list of ratings from 0 to 9, indicating different combinations of distress extent and distress severities. That's pretty much it that we get out of the database here. One key important thing is that the first column indicates the segment ID. And the segment ID we will use later to link to a shapefile. So the shapefile that we are using is called Provo Streets 2011, and it is obtained with permission from the Utah LTAP. And we'll show you kind of how this is set up real quick. In here we have some of the same types of columns. We have a label column that we use. There are lengths, and then the important one is here, RIN number. RIN number, these numbers here match to the database. The objective of our of this program is to generate an atlas of pavement segments and then display those attributes that are listed inside the streets shapefile and also in the database onto the atlas page that is printed to a PDF. So the code was generated in Python using many features from ArcMap. We have a little descriptor here. So the first thing we do is we read in the script arguments from the script in ArcMap. And the important things that we're bringing in is we are bringing in the road shapefile itself. We're bringing in what field, the name of the field that we want to join, and then the new field links to the database join field. And then we have some other files that we needed to use in order to make the conversion between the two pavement distress methods. And these files are used to do that. We also wanted to calculate the slope for each of the segments, so we imported DEM to be able to do that. We have some files from last year's project that describe the soil properties, the variance in the soil property, and then we allow the user to specify the output file path and the output name of the file. Okay, so I'm going to skip this section real quick that talks about declaring a function that we call later in the script, but we'll come back to it. And we'll talk mainly about some of our geoprocessing functions. So the first thing we do is we take the input shapefile, which was, in our case, in this example, is called Provo TAMS 2011, and we copy it to a new shapefile. These lines right here, we are joining the shapefile and the database together based on the input fields from the parameters, from the script parameters. Then we select from that field we select to a new shapefile, and we call it the output name. Then one important thing is later we're going to be generating points from the endpoints of the shapefile, the input shapefile. And one of the problems with generating points is that if you have a road segment that has null geometry, or rather has no vertices but has attributes, there's no way to generate the point shapefile from that. So what we do is we go through and we go ahead and delete those, and that's what this repair geometry management function is doing. Okay, so then once we've selected out, we can go ahead and remove the join from the original shapefile and then check to see if the output layer already exists. If it does, we're going to go ahead and remove that layer and then add the new one back in. So that's what these lines are doing here. Now we're going to create a new field called PCI. Remember, the PCI is the new updated pavement method that we're trying to extrapolate from the old methods that TAMS was using. So we go ahead and create a new field called whatever the user wanted to call it, new field name. The default is PCI. Then we're going to associate the field names in the shapefile with the TAMS rating. Okay, next we create a cursor to go ahead and iterate through the rows in our output file. And then we create this loop here that does exactly what I said. We're extracting the value of the distress rating from the row in the attribute, in the output field. And then for each of those rows, we're going to go ahead and calculate, for that new field we generated, we're going to calculate the PCI. And so I created this function called PCI that inputs the distress ratings from each of the 7 ratings that are critical to calculating PCI. The next thing we wanted to do is to be able to calculate the average values for some of the features, like the resilient modulus and the variance. So in order to do that, we had to, it's basically trying to get the values of in a line segment from extracting the values from the corresponding raster values. Basically what you have to do first is convert the line segments to points, and so that's what we do here. We convert it to points, and then we use this extract multi-values to points function here. Okay, so then we create new fields called low and high confidence intervals, and then in these lines we calculate the confidence intervals based on the variance extracted from the variance raster. So now that we have all the information extracted into a point shapefile, we want to do some calculations. So what we do is we set up a cursor again on the point shapefile, and we iterate through the rows in the point shapefile. And then we do some calculations depending on what type of value it is here. So first the cursor runs through and it just grabs all the values and extracts them into a list. So basically we have lists for each of the 3 or 4 in this case fields, and once we have those in an array, then we can go ahead and do some calculations and export to a new array. Okay, well that's about it for the geoprocessing. Now we're into exporting the information that we extracted from the database and the attribute table, exporting that to a PDF file. So first thing we do is we declare a new cursor that on the output file, and we'll set that equal to rows. We'll declare our current map, or our MXD file to the current map that we have open, and then we will create a path file that says where we want to save our atlas, our new atlas that we're going to generate. Then we check to see if the atlas exists. If it does, we remove it, and then we use this function, PDF document create, to create that PDF in that path file. At this point, this PDF is empty, and we will be appending pages to the PDF document. Okay, so I use this I for a counter because we're going to want to count through the arrays that we created when we extracted the values from the points and the line attribute tables. And then we create this loop, and this loop right here runs all the way through the remaining of our program, and it is looping through each of the segments and creating a new PDF page based on the information of the line segment. So again, we redeclare our map document to be current. What we're doing in these lines here is making sure that the file that we create later in this loop called temp selected is no longer in the map layers. Then we create the shapefile path based on the input parameters from our script file. We form the name of the output file, which is going to be pavement underscore section underscore, and then the name that is in the attribute table of the row that we're on through our iteration. Then we check to see if the path exists already. If it does, we go ahead and delete it. I don't want 3,700 something segments shapefiles to show up in my ARC catalog, so we go ahead and use that to delete those. So we declare a buffer width. The buffer width is based on the width from the shapefile attribute table. We're running the buffer analysis here based on the name and output folder that we declared previously. These are each of the elements that we have in the MXD file. So what we're saying here is loop through all the elements that are shown in the MXD file. If the element name equals something, for example this segment name, then we want to change that to be to call it from the attribute table. Now that all of our elements in the page are declared, we're going to go ahead and remove the temp selected layer if it exists already, and then we're going to start exporting our our new updated MXD file to a new PDF page, and then we're going to append that to our atlas. And then we do a little bit of cleaning up here. We're going to refresh the table of contents, and we're going to go ahead and remove the layer that we created. That's about it for the code. I know we went through it pretty fast, but you can ask Tommy or I about it later if you have any questions. So now we're going to describe a little bit about the script and how the script runs. Let Tommy do that.
In ArcMap, we have it so that we can just open up the script, right? And right now we have all of our defaults on that we wanted to, so it didn't take so long to put in because there are so many input elements. Here we have the first TAMS road shape file. This is the Provost Streets 2011. We know that it was the RIN number we needed to join to in the TAMS database, but technically we could put in any name from that database. The new field name that we want to create will be called the PCI. We need to go to the table or the database location, and this we could use to go to it, but like I said, we already have it as our default. Then we want to join the field, the segment ID. This is all explained, was explained already in the coding, but we just have them all as the default. But if you can see over to our right, it has all we have described all of these things and what they do and what we need to have them do. So this is usually the segment ID, or it's just the first location of the table location in the database. Kirk already explained the deduct CSV values and the corrected deduct CSV values. So that's where those are inputted. Here we put in our DEM, and this is where we wanted the Provo City DEM. This is where our resilient modulus is, and variance. Technically, we could change all of these things and make it into any city, pretty much in the whole US or anywhere. This is where we specify the output name that we want for the file and where it is found. If we push OK here, it will run. I'm just going to have it run for a little bit. So as you can see, the first one has been done, a pavement selection now second, and we're just going to go to 3 or 4 of them here, and I'm just going to cancel out, and we're going to go look at what it has created. It is saved into our folder where we previously desired it, but here is one that we previously had done. So as you can see, the road is actually outlined. It's pretty nifty in this red, and it is that's the extent that it is shown down in the bottom right hand corner. The whole window is down here. We have the name of the street, where it connects on one side and where it connects on the other side, which is way cool. We have all of these different elements of that road listed down here. It was all done in the script, and yeah, that is pretty much how this went.